All right, my name is Victor Gonzalez.
My name is Drake Stevens.
And I'm Daryl Longoy.
And as well, our other members that unfortunately aren't here today are Noe Ortiz and Suyun Sun. And so today we're going to present to you SolarChain. So given the rise of blockchain and renewable... sorry.
Continue.
Okay, sorry, it's fine. Given the rise of blockchain and renewable energy, we decided to tackle an interesting problem that we realized was pretty occurrent with a lot of different companies that have tried to both combine renewable energy and Ethereum. For example, one company such as Grid Plus, where they were attempting to sell energy from peer-to-peer using Ethereum, we realized that the issue with their design is that it wasn't purely peer-to-peer. It was mostly selling renewable energy from one house to an intermediary and then back to the grid, which eventually would be sent back to another user. So we decided to tackle an interesting issue here, and what essentially is having 3 different houses as a proof of concept design, having 3 different houses communicate with each other, figure out what their battery levels are, and then eventually reaching an agreement as to how much energy they would like to transfer to each other, reach upon an agreement through socket programming, and then eventually perform, verify, and execute the transaction over the Ethereum network. So I'm going to hand it off to Drake, who will talk over hardware.
So our hardware design, we're representing 3 different houses. Every house would have its own solar panel, its own battery, and its own sort of system that we made of hardware to allow one house to change to different states depending on the battery level. If we find that we have excess amount of energy in our battery, it's reaching near max capacity, but we're still generating power from our solar panel, we can change system of relays to be able to send that energy from one house to another and record the transactions through our Raspberry Pi running our Ethereum to enable this excess energy that we're generating to be sold instead of wasted. On the opposite side, we can also detect if our battery is reaching a low max capacity, then we might say, okay, we're going to need more energy in our battery in order to run our house. So we can go out into the Ethereum network we set up, say we're looking for more energy, and then switch the system of relays in order to accept energy. So at a certain point, we'll have a house with excess energy offering to sell, and a house with not enough energy trying to buy. The relays in each individual house will automatically set up to connect the 2 houses in order to start transactioning the energy, as well as accurately recording it and reporting back to that Raspberry Pi in order to securely and accurately transaction the energy from one house to another.
Okay, so in terms of software, it was a pretty complex array of different programs. First of all, each of our Raspberry Pis ran a custom Raspbian distribution, which is Debian-based, and our code was originally written in JavaScript because the Ethereum dependencies were also written in JavaScript, and eventually we had a lot of issues with that, so we just ended up porting our code to Python, which also had existing libraries for Ethereum, which worked really well. So our Python code eventually, whenever it would try to communicate with the Ethereum network, we were using the Rinkeby test network for Ethereum, which is much more simple, and we could just port, free Ethereum into our network, but it's essentially worthless because it's strictly for testing purposes. So eventually, we ported some of the Ethereum into our accounts, which were represented by each of the nodes. We then communicated with the Infura network in order to facilitate the Ethereum transaction, and then eventually that would be verified by the change in node balance that each of the nodes had independently. That way, that served as a verification aspect that the transaction was actually occurred, as well as having two-sided, what's called the two-party verification. One would verify that it received a certain amount of energy, and the other one would verify that it sent out a certain amount of energy. And that's, of course, compensating for different discrepancies in change in voltage or change in current. If you guys have any questions, you're welcome to ask them. Yes?
And so in many solar installations, they are, depending on where you are, required to be grid tied.
So you guys are kind of trying to avoid using the grid, but what's the limitation on the size of your network? Because you have to are you doing a peer-to-peer direct relay system, or are you doing a hub and spoke? What are you doing?
Right now, this is currently a proof of concept design for 3-house peer-to-peer network. If we were attempting to fully maximize it and scale it up, we realized we were running into different issues. For example, running a lot of different connections at the same time from one house to another. We also ran up on different ways of complementing that, and instead just having one node tying several houses together and then another node tying other houses together. So that would limit and cut down the amount of connections going to each individual house. So in this case, to answer your question, it's strictly peer-to-peer. We were attempting to do grid, but we realized it would be much more simple to just have it strictly peer-to-peer and only have main as backup power.
As far as, as far as scaling it out, it's not an issue about the number. We can change it from 3 houses to 100 houses. The main issue is the distance. We can't do like one house in one city, another house on the other side of the country like this. It would have to be, we're thinking more of a neighborhood scale where. And then as far as the system of it, instead of having like one spoke, one central point, it's more of a loop with a few different pathways options. So that way, if 100 houses with 50 different transactions going on at the same time, it's still able to work like that. It'll be a large, using like telecom standards of information going from one to another. We're using the same for competitors.
So, I mean, it's a great idea what you guys are doing there, and you did bring out the point, the fact that the proximity is important here. And given that fact, why use blockchain? Can you not use existing connections because you're going to be limited by the number of entities and the relationship? Why blockchain?
The reason we preferred blockchain is over its simplicity and its security. As of late, I recall it's 256-bit encryption, and not to mention that every single time a transaction is performed, it's verified by its peers, and at the same time, by using blockchain, it kind of just also coalesces the fact that we have this localized energy value, and it's just simple to just sell out to one other person. It's hopefully becoming the trend as well as in terms of a new currency.
So for the verification, are you exchanging some kind of keys, stuff like that, IPsec or something?
We actually tried originally creating a localized Ethereum network with its own custom smart contract. However, that proved to be very troublesome because the mining time and the verification time took a great deal of resources, and we attempted to use it on one small laptop, and that didn't prove to be enough. And so, given budget, we just decided to not go with that and instead do it through the Ethereum test network, the Rinkeby test network.
Folks, let's thank the team.